corner, I'm going to talk about two basic CS topics in Python: for loops and recursion, and their applications in the local problem. For loops and recursion are very similar coding methods that allows you to run a bunch of code over and over again until you reach some restrictions. First, let's look some basic examples of for loops and recursion to understand them. Let's calculate the sum from 1 to 100. For the for loop, you have your basic sum, and you have a for loop, and after the for is your restrictions. So let's have an index I from range from 1 to 101 exclusive, and you add the sum each time of the I. So if the I equals to 1, you add the sum to 1, and when the I comes to 2, you add the previous sum to 2, and when 1 hits to 100, you get your sum from 1 to 100. And if one tries to get to 101, then it breaks out from the loop. For the recursion version, we start from 100. So we basically, if we reach n to 1, we return 1 for the function. And so we start from n, from n is 100, and we'll add the sum of the previous 99. And then we start and for this function, we start n from 99, and then add the sum of previous 98 numbers. And until we reach n equals to 1. So in this case, we add out sum from 1 to 100.
So today we're going to talk about locker problem, and which means that there will be n lockers, and students' number n will changes all the lockers whose numbers can be divided by n. So like we will use an example to illustrate the problem. And first we set like 5 lockers so that there will be 5 students. And so at first all the lockers will be closed, so we set it to be false. And so for students number 1, all the lockers will be changed. So all the students will be open. And for students number 2, we can change the status of lockers whose number are 2 and 4, so it will be false. And for 3, only the number 3 will be changed. And for 4, only the 4 will be changed. And also 5, only 5 will be changed. So the final status of the lockers will be true, false, false, true, and false. So only the number 1 and 4, these 2 lockers are open, and all the other 3 are closed.
So here's the solution to the locker problems in for loops. First, we have a function solving locker problems, and we take a certain numbers of lockers. Then we set all the status of those lockers to closed, which I set it as false. Times lockers plus 1. Why lockers plus 1? Because the index in computer science starts at 0. So, however, our number of students start at 1. Like the index of students starts at 1. So we'll have to, in total lockers plus 1 lockers, close. And then we have the same number of students as the lockers. So here is the process of the students change the status of lockers. First, we go through from each student. So from students 1 to students 2 and to the last student. Then for each student, we start at the same number of the student, and we end at literally the last locker. For each step, since each student only changed the status of locker by the multiple of their numbers, so our steps goes to the number of students. And so for each of that student, it change the status of the locker and goes through by that. Then we create a list to contain our open locker. Say open locker and starts with empty list. Then we simply go through every locker, like for each locker, from locker 1 to locker plus 1 but not inclusive, so that's to the last locker we have. And then we give a condition. We judge that if the locker is open, so if its open locker is true, here we say that the false locker is the closed locker. So if the locker is true, then it's open. So then we append the open locker to the list open locker, and then return the open locker list. We will have all the lockers open.
So now we are going to talk about recursion in the locker problem. So it is very similar to the solution by using the for loop. So we also first set the number n to be the number of the students, and we also have two other variables, and I means the index of the students who is going to change the status of the lockers, and p is how many lockers the student can change. So we first set a list which represents all the lockers, and so we will show the solution by using an example of n equals to 10. So we also set the number m to be as small as possible, so we set it to be 1. And so p equals to n double divide m. So we define a function called each students, which means that for each m we change the lockers. So we define a function called each student m and p, which means that we can change the status of the locker p times m. So first of all, if p is bigger than 1, so we can first change the status and return the list of each student m p minus 1, which we can call the function again, and we also plus the list of this part, which means that like if we change the status of this locker, so all the locker in this part won't change because the p minus 1 won't change this part of lockers. So we just call the function again until p equals to 1. So if p equals to 1, we can first also change the status of the list of index of m. So then we do not have to change any other locker status, so we can just return the list. So in this way, we can return the final list which have already been changed by student m. So now the next step is very similar to this step, so we can define another function. And so for each m from 1 to the number of n, so we can also call the function again and again, so to which by this way we can finally return the list which have been changed by all the students.